every keyword that's really important to this audience in a single title of a presentation. So with that, I'm going to turn this over. And just as a quick introduction, I got this description from the team this morning. Their talk will be a very high-level overview of how Webex enables modern Webex SaaS systems using state-of-the-art technology and evolving DevSecOps methodologies. And we'll be talking about a platform that is already in production use on AWS, Azure, and some of the Cisco OpenStack environments. So with that, turning it over to Hasith and Mercion, and we'll get underway.
Hi, good morning all. My name is Hasith, and I lead cloud-native platform efforts within Webex. And joined with me is Mercion, my colleague. So we are going to give you guys an overview, as Gary mentioned, about how we leverage cloud-native technologies to enable Webex use cases. Right, moving on. So given everybody's in a Webex conference today, everybody must be familiar with Webex. Now, here's a high-level overview about scale of Webex. We host many millions of virtual meetings every month, on which participants spend billions of minutes. And in addition, there's billions of messages exchanged in our collaboration platforms. And certainly 2020 has been a very busy year so far, supporting all of our customers through these challenging times. And certainly on our end, it has been many days on which there's been a lot of activities happening. Anyway, let me follow that up with a couple of visuals as to what Webex really is. There's a lot of breadth to Webex. So first of all, it's used in many contexts, and you can see on the top left-hand corner, from real-time whiteboarding to conferencing in rooms, huddle spaces, and even public conferences. And then this is also Webex. So starting from the very famous Cisco IP phones to soft clients, whether it's on a laptop or a phone, and on my top right hand, the most state-of-the-art personal conferencing device you can get in the market today. Now, moving on, I guess everybody is well aware of Cloud Native Foundation and CNCF efforts. Now, we have an initiative inside Webex called Webex Cubed, and the aim of Webex Cubed has been to lead cloud native efforts within Webex to see what we can do to enable Cisco Webex use cases at scale. And moving on. So what does it mean to engineer for Webex? So first is it's the sheer scale. So you have to actually think of being able to sort of bring up and manage, maintain hundreds of Kubernetes clusters with thousands of workers, lots of different configurations, network topologies, providers, private cloud, AWS, Azure, GCP, many, and this across many different global locations. In terms of operating system wise, majority is Linux, but we do have some Windows workloads as well. How do we manage the differences between the two, and can we make it homogeneous across Linux and Windows? Many types of workloads. So you have stateless, stateful services. You have real-time media, you have microservices, you have applications that are monoliths, and all of this with comprehensive security requirements at heart, because that's something Cisco is well known for. And then it also comes down to people and processes. So in terms of people, engineering is spread across the globe and lots of different cultures, particularly when you are looking at adopting DevOps and moving on to cloud native technologies. It does require a change in mindset. How do you effectively drive that change in mindset? Then processes also need evolution, particularly cloud native technology is not going to be effective unless you evolve the methodologies and processes along with it, because that's also part of how you gain the benefits, realizing the true benefits of cloud native technology. Now, we're going to take a legacy use case that we used to leverage cloud native technologies and transformed, which we'll get into later. So before March 2020, for some of our media use cases, this was the rough architecture. It is containerized, so it's not, we weren't starting from IaaS. So on the left-hand side, you can see using ChatOps and for some of the management aspects, Jenkins pipelines. And in the control plane, it's some event-driven, and we have custom state machines doing certain tasks. And then in terms of managing the infrastructure-wise, it's API calls and SSH. Now, some of the good things, we were leveraging this architecture and doing daily hands-off application deploys at different global windows, pretty much in a near hands-off automated fashion. There were canaries and validation built up. IaaS changes were tied in with the application. So if you're changing OpenSSL version, you can roll out your OpenSSL change with the next application deploy. Now, some of the not so good things with this system, it's too bespoke. There were many thousands of lines of Python code and state machines and things written up to handle the orchestration. It was done for a specific purpose, and therefore, in the wider context of Webex platform, we couldn't really leverage it. And then one thing that was clear was, yes, we were doing it for a few thousand nodes, but certainly there were serious scalability problems when you look at scaling it beyond, having that centralized orchestration, and doing SSH connections to lots of nodes from one place is not the best idea. It's gonna have its limits. Now, some of the high-level architectural goals for WebEx Cubed. So first is the control plane. We wanted it to be turnkey and portable, and tied to a specific administrative scope and boundary. And the reason for that is then you can maintain good hygiene across environments. So for development, you want a separate control plane. For integration, you want another. For production, you'd want another. If you have environments like FedRAMP, you want a completely separate control plane for that, and give that complete administrative isolation. Then standardized deployments across deployments to applications. So it really should not matter for an application whether you're going to be deployed in private cloud or in AWS or Azure. And ideally, the other thing is for it to be common across all the environments. So at this point, we have things pretty much standard, whether it's in dev test labs, integration, or production. We don't quite have it all the way to a developer's laptop, but that's where we would want to try and get to. Then enable state-of-the-art security. So what do I mean by that? So security does not need to be enemy of convenience, and people often treat it like that, and that's why security is hard. So the idea behind this is we would evaluate every single security challenge we come across and ask simple questions. Like, for example, you have a requirement for a password, and then if you're taking the implementation, you'd be looking at enforcing the password policy. But the question to ask is, do you need a password, right? Can we do it with short-lived tokens? Can you do it with MTLS? So questions like that. And then you have other things like ACL requirements, and you could think of evolutions of processes around some of those things. Would be, rather than it being processed, can we be declarative around ACL requirements? Can we put sort of very comprehensive, relentless automation where security is involved? Then the next point is full stack reproducibility. So even Kubernetes clusters, we want to treat them as cattle and very much be able to destroy and recreate. And then the last point, we are not quite there yet, but definitely one of our aspirations is being able to have a good night's sleep during a major Kubernetes version change across our production environments. Yeah, so anyway, I'm now going to hand over to my colleague Mercion, and he'll dive into more details about Webex Cubed and how we do things there.
Thanks, Hasith. Hey, folks, my name is Mercion. So this is the 1,000-foot view diagram that we try to we spin up, and people ask us, what is Webex Cubed? So at the top level, I'm going to be talking about 3 classes of clusters. Everything here is Kubernetes. So the first thing, starting off with our class A cluster, right? And that's our command and control plane on the top left. This is our control plane cluster that runs within the secure perimeter, within the Cisco, within our management internal networks. And this is what enables our orchestration and enables our DevOps. So when Hasith pings me on a Friday, just after lunch saying, hey, Mercion, by Monday, we need 2 new clusters in Singapore, this is where we would go. And this is what is in charge of bringing up the clusters. All of the changes that we drive into our infrastructure, whether it be dev, integration environments, production environments, is done through GitOps. So when you want a new cluster, you would define the cluster. You'd write the, it's about 10, 15 lines of YAML to say, hey, I want a cluster. It's got to be in AWS. It's got to be in Singapore. I want 200 worker nodes. So the DevOps engineer would define the what they would want, and they would create a PR, and that triggers the creation of the cluster, and that happens in the command and control. Within the command and control, we use kind of common tooling like Terraform and Ansible, and we have components like Argo, Atlantis, Kafka that we have deployed in there. We have a whole bunch of custom in-house applications as well, like KD API, single pane, and things like that. But in effect, when that change hook comes into the command and control, it calls the IaaS APIs, it brings up the infrastructure, and it provisions a cluster, it creates everything, and deploys the application workloads onto them. So that brings us to kind of the Class C clusters, which is the at the bottom there. Those are our application clusters, right? And those are the clusters that run our customer-facing workloads. They're as you can see, they're multi-cloud, multi-provider. And the key thing there is when we talk about Kubernetes clusters, we don't just give a vanilla Kubernetes cluster to our application developers. We have a common platform layer that we deploy on top of Kubernetes that provides things like logging, metrics, certificates, messaging. There's all sorts of kind of common services so that the developer experience when they deploy onto a cluster in AWS has to be exactly the same if compared to deploying to Azure or VMware or OpenStack on-prem. So that gives us the kind of a reproducible common environment for application developers. And the nature in which we bring these clusters up is that it allows us to kind of scale across those different providers easily. The other thing is a Class B cluster, clusters that I haven't talked about yet. So the Class B clusters are the things like the Observer cluster and the Regional Manager. And they are clusters that are deployed out there in different regions, but they don't touch customer traffic or data. They're there for orchestration purposes. So one is that we have our Observer cluster. The purpose of the Observer cluster is to give developers and DevOps engineers a single place to go to look at their application logs and metrics and alerts, irrespective of which provider it's running on, which environment, and it's all in one place. The other one is the Regional Manager. As I mentioned before, orchestration happens from within the Cisco Secure Control Plane cluster, Command and Control cluster, which is a Class A cluster. But some things it doesn't make sense to do some things remotely if in some ways. Some actions take a large amount of time. So the Command and Control will delegate certain orchestration tasks to the Regional Manager, so that the Regional Manager cluster in Asia is what's doing some of the orchestration to bring up the Singapore cluster. It's not all being done from the same place and a single point. Delegating it out to the region so that the regions, so that there isn't a single point of failure and there's a little bit more autonomy. So if you go to the next slide, can you go to the next slide, Steve? Oh, there we go. Yeah, so that's 1,000-foot view. Using that architecture, we've deployed, thousands of instances, tens of Kubernetes clusters. I think I would say almost hundreds if you think about all the ones we've destroyed. But we're able to use that tooling to deploy the clusters very quickly. We've been able to bring up new clusters in new regions over a weekend and have it ready. Start on Friday and it's ready by Saturday lunchtime. There's a bit of soaking and it's taking production traffic by Monday. That ability to deploy clusters in a reproducible manner across providers and regions means that we have flexibility, right? We have flexibility around regions, we have flexibility around availability zones and instance types, so that if it makes more sense to run in Azure, we can run in Azure in a region. We can move that workload around as it makes sense to us. If you go to the next slide, the other thing I wanted to touch on here was rebuilds and migrations. And this is something I think we do that is kind of different to how the rest of the people out there do it. It's that we don't really we don't really care about, they're not pets. Our clusters are just cattle. So when we need to do something like, hey, there's a base image update, there is a new version of Kubernetes, when there's a fundamental change, we don't do upgrades of our clusters. We just destroy everything and build them back up. So if I take an example of what we did, I think a couple of months ago in Frankfurt, we had hundreds of nodes deployed, and we realized, hey, we're running out of IP addresses, and the subnets we've allocated to the pod subnets we were running out of IP addresses in the subnet. What did we do? Well, on Friday we started to drain customer traffic out of Frankfurt. Saturday morning we destroyed everything, and we then rebuild everything, and then around lunchtime we were ready to start to move traffic on, and then slowly by Monday morning we were taking peak traffic again. So the approach we've taken of anytime we want to do a change, just destroy everything, rebuild everything. And actually, it's not just when you want to make a change. We have kind of a unwritten rule within the team that any cluster that's been up for more than 3 months, you should destroy. Anything that's been up for more than 3 months, we just tear it all down and bring it back up. And we kind of cycle through our clusters and always keep them fresh. And that allows us to validate the tooling and to ensure that, hey, if there is an outage, we can replace that cluster quite easily. And this kind of operational model has meant that we were able to, at a fairly brisk cadence, roll out Kubernetes version changes and other major changes without any major incident. The other point I just wanted to touch on was the operational aspect of it all. So this project kind of grew very quickly. And we got very good at creating lots of clusters and creating and reproducing stuff. But creating lots of Kubernetes clusters and lots of workloads is one thing. Managing them at scale is a whole different ballgame, right? So a couple of points, the attributes that we have in our architecture, I want to touch on here. One is we have centralized visibility through the observer cluster, but decentralized alerting and reporting, which means that although all developers go to one Grafana for every cluster and every region, the actual alerts, if there's an error in a cluster, it's that cluster that's actually sending the alerts. The metrics are stored in that cluster. This cluster is fully sufficient and able to alert and provide even visibility by itself, so that there isn't a single point of failure when it comes to alerting. The other point I want to touch on was network visibility and monitoring. For media, this is key, right? Nobody likes to be in a meeting when there's packet loss. That's something we built into our clusters from a very early stage, validating throughput and latency and jitter between pods in the same cluster, between services in different clusters, across regions, across different providers. That has been super important for us. So we've had to build in a lot of metrics into our cluster, so we have that visibility. And the third point there I want to quickly touch on was continuous testing. The approach we've taken to testing is that when we bring up a new cluster, we don't test it and validate it and say, oh, now I've run these tests, the cluster is okay, we can put customer traffic on it. Instead, we say anything that's worth testing, you should be testing all the time. So we've gotten to the point now where when we scale out and bring up a new cluster, if I don't get paid from that cluster, it's got to be good to take for customer traffic. It doesn't need somebody to poke around and validate stuff's okay. So continuous testing based on alerting and no one-off tests is a key tenet of our operational model. So if we move on to the next slide, what are the key takeaways, right? For us, this has been a bit of an insane journey for us. We've had to scale and roll this out much faster than we anticipated in January because of scaling requirements. One thing that we've done is migrating to baked images. So we didn't get this right when we started off, right? When we started off, we were creating instances in Azure, AWS. We were running Ansible. We were configuring the instances, creating the cluster, pulling down containers, but that just takes way too long. If you want to build, a couple of 200 node clusters in a matter of hours, even simple things like the sheer act of pulling the Docker containers takes time, and that's time that somebody's waiting around, and that's not good enough. So what we've done is we've tried to move the vast majority of configuration from runtime configuration to being baked in the base images, up to and including those Docker images. So if you know that every cluster is going to pull these 10 Docker images, we bake those into the base AMI image in AWS, so that the Docker cache is already populated by the time the VM boots up, so that you don't even need to waste time pulling down the Docker containers. The second point was automation. We are a big fan of automation. Everything we've done has been automated when we even started, when we were kind of getting going. But we realized that ops engineers and DevOps engineers were spending too much time doing, I'll run the automation for provisioning a cluster, then I'll pivot, run the automation for deploying the cluster, then I'll pivot and run the automation for validating and making sure everything's okay. Automate things end to end, so that single first commit to say, I want a cluster, and then don't have them log into 10 different UIs to validate stuff. Have it automated end to end, so that you reduce the toil of the ops engineers, and that also allows us to do it more often and more quickly. The third point is a key point for us as well on testing and validation. It's not just about testing your clusters and your infrastructure. It's about testing the code that builds up your infrastructure, right? Because we destroy and recreate clusters at almost on a multiple times a week. We have spent a lot of time testing our tooling. So when Hasith says, hey, we need to scale up, we have confidence in our tooling. So doing it continually and testing and validating the tooling, I think, is almost as important as testing and validating the platform itself. And the last point I just want to touch on was that Kubernetes is not just stateless HTTP microservices. We run some pretty weird workloads on Kubernetes, stateful services, media, whole conferences, and people say those aren't microservices. That's not stateless. But Kubernetes is inherently flexible, and we've actually made it work. So I just wanted to call out that, hey, Kubernetes is not just for stateful HTTP. You can run media. We run Windows containers on it. we run all sorts of stateful, ancient crap on it, and hey, it works. So big shout out to Kubernetes.
Thank you for listening, guys, and special thanks for Cloud Native ecosystem and open source community for making a lot of these things possible. Any questions?
Yeah, I had a question in terms of, can you tell me a little bit more about the lack of testing? So there was a mention about there's a continuous testing. So what is your entry criteria for you to activate a cluster to start taking traffic? Because I might have misheard it. The way I felt was you do the testing while the workload is taking. I think there's more to it than that. I think I just wanted you to elaborate on that.
Yeah, so our approach changed a little bit, right? So initially what we had was we have a new cluster, a new environment up, and then we run tests on the environment, validate that it's ready, and then deploy workloads onto it. That's not the approach that we've adopted now, and we've evolved a bit. And it's saying that any test that's worth running once during the validation phase is worth running all the time. So what I meant is no one-off tests. There's no one-off validation. So our approach for Kubernetes clusters is the cluster is part of the core infrastructure buildup and the cluster stand-up. That deploys the test to the cluster, and they run as services in the cluster, and there's a continuous validation and metrics. So we don't have that. Is the cluster okay? Ideally, what we want to get is if I don't get paged or alerted from the cluster, it should be ready to take production traffic. And that's what I meant by no one-off tests, is that I think some people like to build a cluster and then run some tests and stop, and say, now deploy production traffic onto it. Yeah. Did you have something you want to add to that, Hasith?
Yeah, it's a service test as well. So test against production and everything that validates not just Kubernetes, it's the application stack as well.
Yeah. Anything that's worth testing is worth testing all the time. And there's no point doing one-off tests, is what I meant.
Guys, we also have a question in our Q&A chat. I'm going to do my best not to step all over my tongue on this one. So if Class B is a central observability stack cluster, do you send all Class C logs to Class B cluster? If yes, do you see any issues and challenges with scale or latency from when the event happens on Class C to seeing it on Grafana?
So go ahead, Mercion.
Yeah. So there's a point here. So yes, there is latency. There's always latency. But the thing is, the alerting and monitor the key things, although you have an observability cluster and a central point where you can view things, all of our alerting and the rules, the Prometheus rules, actually live in each cluster. So we want to make sure those alerts get fired and there's no latency there. So the logic actually happens in each cluster. All the central observability cluster gives you is so that engineers don't need to go to different places. So yes, there is a bit of latency. We use Thanos for, especially from a metrics perspective, to do it. So even when you go to your central observability cluster, it's actually Grafana is hooked to Thanos, which in the backend is going to that cluster you want, pulling the data out, it's doing the deduplication and giving you that pretty dashboard. So there is some latency and scale issues there, but it's not, we have 50 plus Kubernetes clusters globally, and it's not been an issue.
And to add a little bit, when you say about latency, we are talking about seconds. It's definitely within a minute when it comes to aggregation. And some of the other points is it is possible for logs and metrics to be viewed locally if you want in specific clusters. And also the other thing is, like, as we build on things, there are definitely legislative reasons. For example, you'd want to keep certain things in a specific region. So there's a lot of flexibility in terms of how we configure it to meet the business need in question.
Great. Thank you both. I think, do we have any additional questions for Hasith and Mercion? Akash, I see your question about the sessions. We're not actually doing hands-on sessions this time around. This is the first time we're doing ScaleX, so I think that there are some things that we can learn from what we're doing this time and maybe evolve it for the next time that we do it. So maybe as we look at doing ScaleX for the second time, we could do some hands-on labs, do some things a little bit different other than the presentations. Thank you for the question. I understand it's 10 o'clock in the evening in India, so I feel your pain in terms of sort of starting to fade out. But like I said, all of these videos will be up on the web shortly, and actually we'll take your suggestion as a great way to maybe evolve ScaleX the next time we do it. Any last questions for Hasith and Mercion? All righty, guys, thank you both very, very much. With this, everybody, we're going to go into our morning break, and we will be